so distributive is the property we see here, and there's the hand motions right there, and that's what we want to do. That's exactly right. You've identified it. Even if you couldn't call it the right thing, you knew what to do, so that's good. So we get 25a equals 18a minus 36 plus 8. And after we've simplified that, we want to stop and kind of look at this and say, well, what else do we need to do, right? Is there more simplifying we can do? And I see a couple things. Do you see a couple things we could do or should do? The negative 36 and the 8, those are like terms, aren't they? So maybe we could do that next. We'd say 25a equals 18a, and then negative 36 plus 8 is? Negative 28. You are right. And now, maybe one more simplification. Did you notice that if that's the equal sign, did you notice how that there's an a on the left side and there's an a on the right side too? We need to combine those. What's that little saying? So let's get the little one here. Yeah. So
That's mean. That's
it is sort of mean. The little one. I'm not telling you to be mean. It's just a saying, right? So the 18a would be the little one. How is it that we deal with the little one? We subtract. That's right, because it's positive 18a. We'll subtract it over. So negative 18a subtracted, or negative 18a from both sides. What is 25a minus 18a? 7a. Yeah. So 7a is equal to negative 28. And we've done a bunch of simplifying, right? We've done a bunch of algebraic simplification to get us to this point. And there's really only one equation solving step we got to do. Is the a right now by itself?
No.
It's not. What's with it?
7.
How's it attached?
Multiplication.
So we need to provide those questions, like that logical, hopefully, process is what I want you to be thinking about. So like you said, I do divide by 7. And so a is equal to negative 28 sevenths, which could be reduced. Negative 4. So a would equal negative 4. So most of the time, I think really all the time, these harder equations are going to be harder because you got to simplify first, right? That's going to be the hard part. I think we'll see that coming into play with number 6 as well. What about number 5? Any questions there? We'll practice this in a little bit. Okay, so number 6 then. Number 6 says clear fractions first. So show of hands, how many of you just love it when a math problem has a bunch of fractions? There's always one or two folks that don't mind fractions. He loves them. He doesn't just like them, he loves them. Okay, pretty strong. The truth is, whether you love fractions or you don't love fractions, they can add a layer of complication, right? And so what we're going to seek to do with a question like this, an equation like this, is we are going to seek to eliminate the fractions or clear the fractions first before we worry about any equation stuff. You can solve this without doing what I'm going to show you, but I feel like what I'm going to show you makes it easier. Make sense? Okay, so check this out. I'm going to rewrite down here, just so I have a little bit of extra room, 1/10 x plus 4/5 equals 9/2. And here's the procedure to clear out the fractions. Let's look at all the denominators, 10, 5, and 2. What we do here is we look for, or we think of, the least common multiple of all three of those numbers. So 10, 5, and 2. What is the smallest number that they all go into evenly?
10.
10, right? 5 goes into, or 10 is divisible by 5, 10 is divisible by 2, and of course 10 is divisible by 10. And here's what we do with that number. This is where it's a little bit different. We're used to using a common denominator for that. What I'm going to do is I'm going to take that 10 that you guys identified, and I'm going to use it to eliminate the fractions. Here's how I do it. I'm going to multiply every single term by 10. I want you to think, before you object or feel like maybe this is wrong, I want you to think about what I'm doing. Aren't I multiplying the left side by 10? And the right side by 10? Isn't that allowed with an equation? Aren't you allowed to do something to one side as long as you do the same thing to the other side? I'm essentially multiplying the whole left side by 10 and the whole right side by 10, which is perfectly allowable. It keeps the equation balanced. Make sense? So let's look at what happens when I do that. If I multiply here, 10 over 1 times 1 over 10, don't we just multiply the numerators together and then the denominators together? So I would get 10 over 10 x. That's pretty happy because in the next step, what's going to happen with 10 tenths? It's 1. The next one, I'm going to multiply this 10 over 1 is times the 4/5. And just like before, I'm going to multiply the numerators together and then the denominators together. 10 times 4, 40. And 1 times 5, 5. So that looks kind of complicated, but think for a second. 40 over 5. That's going to end up being 8 here in just a second, isn't it? That's good. It's not a fraction anymore. And then finally, the last multiplication, 10 times 9, 90. 1 times 2, 2. So it's like, wow, that's going to reduce also. So let's go ahead and do all these reducings. 10 tenths is 1, so that's just 1x. 40 over 5, like you guys said a second ago, is 8, so plus 8. 90 over 2, 45, like you just said a second ago. We just took something that at the start, you got to admit, that looked kind of complicated. We've reduced it down to being x plus 8 equals 45. Do you see why it's handy to clear the fractions? I hope that you'll buy into that. Our final step here before I get your question, Alec, would be to subtract 8 from both sides. And when I do that, I end up with x is equal to 37. Okay, question, Alec. It's very possible to do it a different way. Yeah, you could just like not clear the fractions at all and still get that. So I wanted to make that point. I said at the start, I'll say it again. What I just showed you, in no way is it required, unless I say clear the fractions, right? Okay. You can definitely do it without clearing the fractions. I just think that that makes it a little bit easier. Okay. And the reason why I would say it would make it easier, I think once you get really quick at this, I think you could go straight from here to there. I think you could skip this step entirely. You could say, hey, the 10s cancel. 40 divided by 5 is 8. 90 divided by 2 is 45. And you jump straight there, subtract 8, done.
And why did you choose 10 over 1? Because it's the reciprocal of 1 over 10?
No, that's a good question. So what I looked at is I looked at the 10, the 5, and the 2, and I asked myself, what is the least common multiple of the 10, 5, and 2? Like, what's the smallest number that they all go into evenly? And it's 10. So that's the way to eliminate all the fractions by multiplying by the least common multiple of the denominators.
Okay.
Yeah. Jake?
So, to start it, you can just find a common denominator, right? And turn, like, say 9 over 2 into...
Turn them all into tenths.
Yeah.
Yeah, you can.
Okay.
You certainly can.
Yep. Right.
That will work every time.
Okay. I just wanted to make sure it worked.
Yeah. For having done this as long as I have, like I personally would clear the fractions. I can do that really fast. Faster than I could like get common denominators and add up all my fractions. I clear them out, subtract 8, done. But you can go with what you think is easiest for you. That's just me. Okay, so a little tougher, right? It's on video, right? I'm recording this right here. So if later on, if you're like, oh yeah, there was that clear the fractions thing. What did we do again? Watch this. Does that make sense? It'll be on Schoology later on today. All right, we got one more, and then we're going to head to the board. If you guys would look forward to number 7. Number 7.
Number 7.
Here it is. Look what we've got there. We've got a bunch of decimals, and it says clear decimals first. So this is sort of like the one we just did. The other one, of course, said clear the fractions first. Isn't it true that a decimal is just like a different form of a fraction? So it's the same concept. I think you'll find this to be a little bit easier, though. Take a look at all those decimals. There are 3 of them. I'll highlight them for you. 0.03x, 0.03 times 15, 0.04 times quantity of 5 plus x. So here's what I'm going to do. I don't like those decimals. I don't know if you do. I'd rather get rid of them, right? So let me just rewrite this real quick. 0.03x plus 0.03 times 15 equals 0.04, parentheses 5 plus x. So here's how this works. I want you guys to count up the number of decimal place values in each term. So for example, in the first term, there are 2 decimal place values, right? 0.03. There's 2 of them. How many in the second term? And in the third term? 2. So what I'm going to do is I'm going to multiply, to get rid of the decimals, I'm going to multiply by 100. The connection is this. How many zeros does 100 have? 2. So if there are 2 decimal places on all the decimals, multiply through by 100. If there were 3 decimal places in there somewhere, you'd multiply by 1,000. If there was somewhere in there 4 decimal places, you'd multiply by 10,000, right? So this would look like this. I'll show you. I mean, it is sort of a little trick. I'm going to multiply by 100. All that really means is that as I multiply by 100, I'm just going to move the decimal over 2 places. That's all it really is. So moving the decimal over 2 places gives me 3x. Moving the decimal over 2 places gives me 3 times 15. Moving the decimal over 3 places gives me 4, parentheses, 5 plus x. So really you could think of this as just moving the decimal over the appropriate number of spots. Of course, you need to move it over a consistent number of spots. You can't move it over 2 spots in one term and 3 spots in another and 5 spots in another or something. It needs to be the uniform motion of the decimal point as you eliminate your decimals. Okay, what do you think? Any questions there? This will be a good opportunity for us to do a little review. If you would, finish this one off. Take just a minute here with you and maybe a table partner or by yourself and see if you can finish. So when you do that, what did you get? Okay, good distributive property there. What else did you do? Perfect. Okay.
And then that came out to be, plus, it was, subtraction. So, I got 25 for 45 minus 20, and so 3x of 25 equals 4x, which subtracts the 3x from the 4x, which is just 1, so 25 equals x.
So I subtracted 3x from 4x. Should I do something to the left side also?
Yeah, and minus.
There we go. Okay, hey, you did a really nice job explaining that. So 25 is equal to x. I think I agree with all your steps. The rest of you feel the same way? We didn't make any arithmetic mistakes, hopefully? Ashlyn, your question.
Well, I got the answer, but I did something different.
What'd you do different?
Actually, I think, no, never mind, I did it that way.
Okay, fair enough. I don't know. It's possible to do it in a slightly different order and get the same answer. Still seeing anything?
Oh, I did 3x minus 4x, and then 4x minus 3x. Before I did.
So you move the x's around first? Yep, no problem. I probably would do the same thing. Her order was fine, your order is fine. Definitely. Okay, please don't let that be a distraction. Yeah, anybody else have a question? Thanks for asking. Appreciate it. Anyone else? Okay. Well, like I said, let's save 8 and 9 for the next couple of days. We'll come back to those. Let's go to the board. We just have a couple of minutes left. Let's try some of these out, all right? So ready, set, go. Head on up.